So for the last couple of years, I've been working on a soon upcoming book called Evolutionary Architectures, and it's about this idea of how do we make evolvability a first-class ability in software architecture. In other words, how can we adapt to the current constant change that happens in the software development ecosystem, because we can't predict the future. Too many unexpected things happen, but if we can get better at adapting to the future, then that's what evolutionary architecture is all about. In this talk, I talk about the three core concepts of how to build an evolutionary architecture and how to retrofit an existing one to make it more evolutionary. Those three pieces are incremental change, about being faster at development and applying fitness functions to make sure that you haven't broken things at the architectural level as you evolve your architecture. Also at deployment, about being faster at being able to deploy and run things side by side to enable capabilities like A/B testing and hypothesis-driven development. I talk about fitness functions as the second core idea in evolutionary architecture, this idea of building tests and metrics and other sorts of verification mechanisms that you verify every time you make a change to your architecture to make sure that you haven't broken some important characteristic of your architecture. And then finally, how to assess what kind of coupling that you have between the components in your architecture. You can't build software without some form of coupling, and a real challenge that we've had over the last few years is finding the appropriate level of coupling that enables us beneficial side effects like the ability to make changes without having to create duplication, but avoiding the unappetizing parts of coupling, which are things that prevent us from making change and moving our architecture forward in an evolvable way. So this talk summarizes the concepts in evolutionary architecture, and it introduces a lot of these ideas that you can take away for both existing projects to make them more evolutionary and how to design new systems that adapt to the changing world a lot more gracefully.